Okay, Lee, in this last video at the very end, you said we were going to begin coding from scratch our first random like noise. I keep saying noise, random like number generator, correct?
Right.
But now we're not
Well,
going to
yeah.
be doing a real pseudo random noise generator
No, we're
starting in this
not.
video. What
No,
what
we're
kind of
not.
system are we making?
This is actually going to be a hash.
Okay.
Now, what a hash does is you give it some sort of input. Every time you call the hash method, which, I'm calling random to make it really confusing for everybody. But every time you call it, you give it an input value. I'm calling it seed because we're working with random numbers, so that's just a common thing. So every time we call this method, we're passing it a number. Now, what a hash does is it takes that number, massages it, does all kinds of crazy stuff with it to give us out an output number that is widely varied from its input but is repeatable. So let's say this hash, I give it the number 5. And then every time I give it the number 5, this hash boils it down, gives me back the value of zero point 0.2. Now maybe I take the same method, give it the number 6, and 6 might come back as 0.98321. So it's one number greater than the last seed that I gave it, but the number I got back is completely different. So
But if you were to give it 6 again, you would get that
I would,
same number back.
I'd still get the 98321 if
So
this was.
definitely different than the way a standard number generator, a random number generator works, where I seed it and then I just say, give me a number, it gives me a random one. Give me another one, I
Right.
get another random number. And so if I asked for 3 random numbers, I'd get 3 random numbers. And with that seed, I would always get those 3 numbers. But in the case of the hash, I'm always expected to send a number in, and I will always get the same single
Number back.
result back. That's a random number.
Right. The hash is a one-to-one. Every input you give it in, you get one, or every time you call it with its input or inputs in our case, eventually, because we're going to be doing 3 different versions of this hash.
Okay.
But you give it some sort of input, it gives you an output. It's a one-to-one relationship. So every time you call the method, depending on the input that goes into it, you get that exact same output every single time.
Okay.
Now, with a random number generator, in our case, what we're working with is a pseudo-random number generator, also called a PRNG, is that we seed it once when we want a new sequence of numbers. We give it some sort of number to fire this thing off. Then we ask it for numbers. And every time we ask it for a number, it's going to give us the next number in the sequence. We never have to seed it again unless we want to reset the sequence of numbers that we're giving it. So in your case where we seed it once and we go, give me 3 numbers. Let's say we seed it with the number 5. And then we go, give me 3 numbers. It gives you back the number 10, 15, and 20. And then you go, okay, give me 3 more numbers. You might get 25, 30, and 35.
Right.
So you're
Because it's
getting,
working its way through that sequence.
right. And those numbers are by no means random, but humans are really bad at picking random numbers. So, but if I were to go back and seed it again with, say, instead of 5, 6, and I go, give me 3 numbers, I might get 82, 47, and 189,000.
Right, because your sequence of random numbers now are completely different based off this new seed.
Right. But if I were to do that and then reseed it again back to 5 and ask it for 3 numbers, it would give me the same numbers that it gave me the first time I seeded it with the number 5, which was
Exactly.
10, 15, and 20. So that is what a random number generator does. It gives you a sequence of numbers, always giving you the next sequence or next number in the sequence. Now, a lot of you have played with random number generators, and they've got various different methods that you can call where you can give it a min and a max, and it gives you something inside of that range. We will be doing that later as well, so we can go, give me the next number, but make sure that this number is between 5 and 10. And you'll get a number between 5 and 10 back out.
Okay.
So we will be doing a true number generator. But what we're going to start off with is going to be a hash, which means we're going to give it a number. It's going to give us something else out.
Now, are you
Now,
using this as just a teaching stepstone, or is this something that you're going to use for real later in the game?
both. I'm
Okay.
starting with a hash because they're simpler, and it's something that we can implement in 3 lines of code, Well, if you count the container for the method and stuff, a few more. But they're really, really simple to put together. If they can get as complicated as you want them to get. But it is something that I want to use in the game for pulling up different numbers. In our train R&D, right now we have train patches that are aligned in a grid, a 5x5 grid, as it were, in my R&D right now. So I've got 25 different patches. Now, I want to be able to take and place grass on my my train patches at some point, and I want this train or this grass to be placed in what would be a pseudo random pattern. But I want to be able to repeat that every single time. So one of the things that I'm thinking of, or what I'm planning on doing with this system, is that I can take the train's patch location in X and Z,
Mm-hmm.
use that to go into a hash, which will give me some random or pseudo random number back out that will always be repeatable. So if I go to my hash and I'm on train patch 00, and I feed that into my system plus a seed, I will always get back a certain number out
Right.
every single time. The patch to the right of me, or of that 00 patch, I feed those into this hash. It
Different
gives me a
number.
number, a completely different number, but it will always be that same number.
Right.
Now, the beautiful thing with this is I get this, pseudo random number out, but it's not a random generator. So I can't use it to generate my grass per se, because if I were to keep requesting that number, I'd keep getting the information back out. So what you end up with is maybe 1,000 pieces of grass all sitting at the same location. Not very useful. But what we can do is use that number that comes back out and use that as the seed to the well 512 that we're going to be building. So we use that to seed or initialize the 512, which will then give us a sequence of effectively infinite number of numbers out of that generator.
Mm-hmm.
So now I can use that to control the position of each blade of the grass, its rotation, its scale. And every time I go back and draw that same patch, because that patch is using its positional information and a seed, which will probably be the patch ID number, because each patch is created with its own unique ID based off of its list. So it'll have its own ID, its location. That information gets put into a hash. It comes back with a number, so it's effectively a unique number specifically to that patch. That number gets fed into the well 512, which then seeds the 512 or the well 512 for generating all my grass and everything else.
Mm-hmm.
So every time that patch gets drawn, every blade of grass will be in the same place, at the same rotation, at the same scale as it was the last time it was drawn.
Right. Okay.
So, but let's get started with that, shall we?
Yeah.
Now, when I first started exploring random number generators, I ran across it at this site. And it was kind of funny how this all worked out, because I was doing a search, believe it or not, for Perlin noise. Now, I was kind of inexperienced and I didn't really understand the topics at hand. And I just did a Google search, and the very first thing that came up was this site about Perlin noise. And if I scroll back down, it goes through this really nice explanation. It's fairly in depth. And then it came into this function that when I was reading it was, wow, that's a random number generator. Great. It's really simple. It's only 2 lines of code. Some wrapper information, but 2 lines of code. This is awesome. So apparently random number generation is not very complex. That's what I thought. Now, since then, a lot of research has gone into this. What I found out is this is not a random number generator. This is a hash. That is one of the mistakes that this website makes. We will visit this website because what it teaches is very good information. What it doesn't teach, though, is how to make a random number generator, and it doesn't teach you how to make Perlin noise.
Even though the site's titled Perl and Noise?
Yes, this is value noise. It's not Perlin noise. We'll get into the differences of what they are.
Mm-hmm.
Surprisingly enough, I think in the next set of videos.
Oh, okay.
So I've got a whole list of videos. We're going to go into value noise, which is what this website teaches you how to do very well.
Gotcha.
So I'm not going to fault it. It's a very good website, very informative, but it is not Perlin noise. So don't mistake this for Perlin noise. Even there was a discussion on a wiki that I read
Mm-hmm.
where Ken Perlin himself commented about the website, saying that this is a good website. But the guy was talking about. He goes, yeah. I was talking to Ken. He goes, yeah, it's a good website. It's not Perlin noise though, because this is value noise, where Perlin noise is a gradient noise.
Okay, let's not get too far away from what we're
So,
doing. We'll come back to
but
this in the noise section.
it's kind of fun. I just wanted to point that out because I didn't realize that myself until a couple of days ago.
Gotcha.
So,
Okay.
of the differences.
Right. So back to hashes.
Okay, so this is what we want to implement. So we can cheat because there's a lot of really long numbers here. So we can copy and paste this part. So I'm going to copy it, but I'm not going to paste it yet. Let's go back over to.
Is there any madness? I would assume there's some madness behind the numbers there that have been selected.
Yep, and I'll get to those in a little bit.
Oh, okay. Cool.
Those are the numbers that people can play with if they want to have fun. The other thing I want to do is we're going to create a new class here. So I'm just going to create it right inside of here. So we'll call this public class myRandom, not to be confused with the built-in random. All right, now inside of here, we're going to create a public static double random 1D. So, but it's not really random. So let's just do this, just so we don't confuse people. We'll call it a hash. So, and then we're going to take an integer and we'll call it seed. Because I don't want to not confuse people too much. I still like a little bit of confusion.
Okay.
That way I can always say when people argue, you just misunderstood what I was saying. All right, now inside of here, I'm going to paste in the information that I copied over to save me some typing. But I'm going to take seed, and everywhere X is, I'm going to replace it. I can do this because we said we weren't going to teach every line of code. We're going to show it, but we weren't going to teach it all. But guess what? I'm still going to teach it. All right, so I'm going to change that. All right, now what is this doing? Hash 1D is taking in a seed. This is a number that you feed it. Every time that you feed in this number, you're going to get back a very specific number that relates to it. The way this happens is it takes the seed, it shifts it 13 bits to the left, and then it XORs it with itself. This gives you something different than what you had to begin with. Then it goes and starts doing some multiplication with itself and adding some other stuff. Now, you had mentioned, what are these really weird numbers? These are prime numbers.
Okay.
These can be chosen at random. Different numbers that you choose here are going to give you different results. So you can go ahead and change this number. You can change this number if you want. And you can change this number if you want. What you can't change are these numbers. Now, these numbers are significant in a different way. If we were to, again, open up calculator.
Mm-hmm.
There it is. Now, if I take the calculator and I go 2 and I raise it to the 32 power, I get this number. This is the max number that you can store in an unsigned integer. So this is its max value. If I divide this by 4,
So we're living in the 32-bit world.
in a 32-bit world because we're doing integers. But if I divide our max integer value or uint value, we get this number, 1073741,824. 1073741,824. That's this number. So what we're doing is we're dividing it by 1/4 of our max number. We're also ANDing or masking with this number. What we're doing is we're taking our seed, doing some bit shifting, XORing it, doing some multiplication operations with itself as well as some prime numbers, and then we're masking it to make sure that it is at most one. It's like, oh, I'm trying to think, is that 1/2? What does this number work out to in real world numbers? Calculator. And go to programmer. And if I've got a hex number, and I paste this number in, I switch it over to a decimal number. Yeah, it works out to be half of our max number. If I multiply this by 2, we're back to this number again. So it's roughly half. It's not exactly half. But what it's trying to do is it's massaging the number, doing multiplication, ANDing it with half to make sure that the number that is here is no longer than half of our max number, subtracting it by 1/4, subtracting it for 1. What this is trying to do, and what it does, not trying, it actually does, is to make sure that the number that you return is in the domain of -1 to 1. Of course, escape IntelliSense bit me.
You can just do a comment, and
Yeah. What's a comment? So this is trying to return a number in the domain of 0 to 1, which is great for what it's trying to do, but not for what we want, because we want to return a double that is in the 0 to 1 domain. So we're going to take this code and we're going to modify it a little bit. So we're going to make another value that we're going to call, or a variable, call it output. Then I'm going to take the information that we get from here, so take this, and I'm going to multiply it, or paste it, yeah, multiply it. I'm thinking Photoshop terms for programming. That's awesome. Not realistic, but all right. Now, what are you not happy with?
well, there's a bit of a parenthesis issue in there.
Yeah.
I mean, you've got 2 openings and you've got 4 closings, so.
Yeah, we'll have to clean it up. But I also want to change a couple of things in here as well. I'm just trying to look at how this is all set up because my code doesn't have this. I'm winging it, as it were. All right. Now, I want to keep all the multiplication and all the prime operations. But when it masks it, instead of using the 7FF, I want to mask it with FFFFF, 8 Fs, which works out to be a 32-bit number. So in other words, whatever this number works out to be, I'm enforcing it to be the a 32-bit number when it comes out of output. And then what I want to do with it is take our output. I'm going to divide equals our output by our integer's max value, which is going to give me a number that is going to be 0 to 1, as opposed, so it should be 0 to 1, at least I think it will be. So this will give me a number, so 1 minus that. Actually, this will give me a number that's going to be 2 to 1, so I still have to do the other number. So 1.0 minus No, just divide it by 2. Two dot zero not float. Now where you still have none. Oh, got to cast that as a double. You're still not happy. Why are you not happy? So this
Well,
is got defined as a long.
Yeah.
What's that? Yeah, I'm trying to figure out how this.
And you can remove the cast out now on the int.max value as well.
Yeah. All right, so if I hit F6, now this is why we built the testing framework and tested it with a normal. Hey, look, it looks just like before. All right, let's go ahead, back up here. Now, our value that we did is a public static, so we can go in here. I'm going to duplicate, actually not duplicate, I want to comment that line out. So I'm going to comment this line out, and then var rand, because I want to switch back and forth between these. So I'm going to make multiple ones so we can swap out at will. So my random hash 1D, and then we can send in a number. We're going to send in X. So hit it 6, build it. And let's see, my numbers are off. So you can see I'm getting numbers greater than 1.
Mm-hmm.
So at some point, oh, let's just put it back to what they had until I can get to the upgraded version. Make sure it's fine. So we can take this whole thing. Okay, where does that go to? Okay, there's your counterpart. So I need one more. And a double and an int. Have I mentioned how much I hate parentheses sometimes? All right, I will get this down back to its normal. All right, so I need 2 parentheses. 1 minus seed, seed, seed. That's fine. That's fine. Oh. So there's 2 there. I'm just basically stripping it out until I can figure out what I had messed up. Okay, so that gets everything there. Now, if I leave this one off for now, I should get a negative 1 to 1 output. So negative essentially 1 to positive 1. Now, if I change that to positive and I divide by, or to our 32-bit, and then I divide by int max value cast that as a double. Should still be happy with that. Okay, so I'm still getting the same thing. I had screwed up the parentheses really, really bad. So what I'm doing is instead of using that odd number, which is slightly inaccurate, moving off to the full. Now, if I get rid of the subtraction here, now I should get, so way low to 2. So it's going from essentially 0 to 2. And then I can take the entire value, divide that by 2, 0. There we go. Now I'm very, very low, 0 to 1. Very accurate 1, which is what I was trying to get to, but it completely tanked all the parentheses.
Let's say it worked better when you actually just slowly built up to it.
Yeah. So I was like, okay, let's go back to what we had, little at a time, go through it all. Now, let's run it real quick. If we look at this, this is doing 4 million iterations. Our numbers are good here. Our distributions are pretty good.
I mean, our mean is 0.50035.
Yep. And here's our duplicates. About on par with what we had with the standard, but this is a hash. So, but remember I said we were going to change some stuff up with the count up at the top, and we're going to change this to be a little bit more real world.
Mm-hmm.
Now, let's go ahead and we'll start off by changing this to go from negative count to positive count, which means we definitely want to change this number because we don't want to do 8 million. So let's go ahead and bring this back down to, say, 500,000. So this should give us 1 million. So, yeah, 1 million operations. Notice our duplicates went way, way down by just doing the simple count, because now we're doing negative and positive. But we want to turn this into a two-dimensional array.
Well, even then, real quick, if you were to comment out your my random and go back to the other one real quick using a count of.
Oh, you just want to see what the.
Yeah, I'm just curious while we're here.
Apparently, I didn't hit 5 in time. So about 231.
So still pretty close to the same.
Yep, pretty close to the same. Now, if I were to turn this into a two-dimensional array, and let's make this one y. Oops, didn't mean to comment that. Wrong button. There we go. So now with this 1D hash, if I want to incorporate both of these information or pieces of information, I don't have a lot of choice. I've got to do like x plus y. So, or x or times y. So if I build that and I run, and
Well, it's going to be pretty big because of the loop in a loop.
yeah, too big actually. I don't want to do that. So let's do 500. Loop in a loop, negative to negative. This should yield 1 million. Same count as before.
Mm-hmm.
Now it rears its ugly head. So I've got a loop in a loop, and I'm using x or the sum of x and y for my hash. Look at how many duplicates I've got. I'm doing 1 million iterations. 998,000 of them are duplicates.
Yeah, wow.
So these are all the unique values that I have. So using a 1D hash is not going to be the answer for what we've got. We've got too many duplicates. We'd end up with the same information over and over and over again. So we have to come up with some better way of doing it. Now, we could also look at, let's say, take x times 0.1f. So just in case it was, oh no, hash is only taking integer. I can't do that yet. Getting ahead of myself, we can look at, instead of using just integer values, start sending in floats. Because when you look at some of the stuff that we're going to have to send in, we're going to be sending in information that is going to be not just integer based, because positional information, especially in Unity, is all based off of vector 2s or vector 3s, which are float values. So we'll also want to be able to deal with the floats. But what I did want to show was the fact that once we start looking at multiple dimensionality of our hash, a 1D hash just is not going to cut it. We're going to have to make multi-dimension hashes to be able to deal with it. So if I use the product, I get a little bit better, but I still have 870,000 duplicates. So what we're going to do in the next video is we're going to take this particular hash and we're going to look at upgrading it to make it a two-dimensional hash so we can handle both of these information and still have a seed and try to get these numbers a little bit better.
Okay. So is that everything you wanted to cover here?
Yep.
All right. Well, with that, that is going to wrap up this video. Thanks a lot.